Sometimes we are asked to find the integral of the product of two functions or the integral of the quotient of two functions. One technique to evaluate such integrals is by using substitution. We are going to divide this topic into 4 different episodes. In this first episode, we are going to use the substitution method to evaluate integrals involving algebraic functions. The main rule that we are going to use is if you have an integral of f of g of x multiplied by g prime of x dx, then this will be written as integral of f of u du using the substitution u equal to g of x. That means we just have to replace the g inside to be another function u, and we have to replace g prime dx by du. For our first example, suppose we have integral of 2x multiplied by x squared plus 4 raised to 20 dx. In this case, we have 2x multiplied by x squared plus 4 raised to 20. Let's try the substitution x squared plus 4 as our u. Then we take the derivative of both sides. So the derivative on the left side will be du. The derivative of x squared plus 4 will be 2x, and we just affix dx. Now, using this substitution, we can rewrite this function as the x squared plus 4 now will be u raised to the power is 20, and 2x dx is actually du. So we have arrived at a simpler function inside our integral, and we can just simply use here the power rule. The integral of u raised to 20 will be u raised to 21 divided by 21 plus c. And after that, you have to replace the u by x squared plus 4. So this will be x squared plus 4 raised to 21 divided by 21 plus a constant c. And that is our final answer for letter A. For letter B, we have integral of 2x plus 7 multiplied by 3x squared plus 21x plus 3 raised to 3 dx. Now, usually, we will let that function to be the u. So this will be 3x squared plus 21x plus 3. Taking the derivatives of both sides, we will get du on the left. On the right, we will have 6x plus 21, but this is with respect to x. Now, let's look at our given. We have 2x plus 7, but this is not 2x plus 7, but we can actually do something about this one. We can factor 3 on these two terms, and this will be 3 multiplied by 2x plus 7 dx, and we just need 2x plus 7 and dx. So we can divide both sides by 3. We will have du divided by 3 equals to 2x plus 7 dx. So our original function now can be written as integral of this function raised to 3 is just u raised to 3. U raised to 3 times 2x plus 7 dx is actually du divided by 3. So we can rewrite this further as 1/3. We can move the constant 1/3 outside of the integral, u raised to 3 du. And now we just simply use the power rule to evaluate this integral. That's 1/3. The power is 3. We add 1, that will be 4. U raised to 4 divided by 4 plus a constant c. So this will be 1 over 12. Well, u is actually 3x squared plus 21x plus 3. So we replace it back. 3x squared plus 21x plus 3 raised to 4 plus the constant c. Let's consider our second example wherein we have integral of f over g. So for letter A, we have integral of x squared plus 1 divided by x cubed plus 3x, everything squared dx. So let's try the substitution u equals to x cubed plus 3x, which is our function in the denominator, x cubed plus 3x. Taking the derivative on both sides, we will get 3x squared plus 3 dx. But what we need is x squared plus 1 dx, not 3x squared plus 3. But we can factor that 3. So this would be du equals to 3x squared plus 1 dx. And we can simply divide both sides by 3. And we will have x squared plus 1 dx, which is what we need in the integral. So this will be equal to integral of 1 over x cubed plus 3x squared times x squared plus 1 dx, and this will be integral of 1 over, so x cubed plus 3x is just u, so this will be u, the power is 2 times, now x squared plus 1 dx is actually du over 3. So we can move the constant outside, that's 1/3, times the integral of 1 over u squared, but this can be written as u raised to minus 2 du. Simply apply now the power rule, so this will be 1/3. The power is minus 2, so adding 1 to it will give us minus 1, so this will be u raised to minus 1 over minus 1 plus c. So we will get now 1 over minus 3u plus c. Or after replacing now the u, you will have minus 3 times the u is x cubed plus 3x plus the constant c. Similarly, we have integral of x cubed divided by 5x to the 4th power plus 2 raised to 3 dx. Now we just use the substitution, u equals to 5x to the 4th plus 2. Taking the derivatives both sides will give us du equals to 20x cubed dx. Now what we need is x cubed dx, so we can divide both sides by 20. So we'll get du divided by 20 equals to x cubed dx. Rewriting first our integral, this will give us 1 over 5x to the 4th power plus 2 raised to 3 times x cubed dx. But after substitution, we will get 1 over the 5x to the 4th power plus 2 is just u raised to power 3 times x cubed dx is actually du over 20. So we can move the 1 over 20 outside, so this will be 1 over 20, which is our constant. Integral of 1 over u raised to 3, but you can put it up, but the power will be minus 3 du. Now simply apply the power rule here. We just add 1 to the power minus 3, that will be minus 3 plus 1 will be minus 2. So this will be 1 over 20 u raised to minus 2 divided by minus 2 plus the constant c. Rewriting this one, we will get 1 over minus 40 u squared plus c. Replacing now the u, we will get 1 over minus 40. Our u is just 5x to the 4th power plus 2 raised to 2nd power plus c. Let's consider our third example, wherein we have radicals involved in our quotients or products. So for the first case, we have integral of x dx divided by square root of 4x squared minus 9. Take note here that we have x dx. If we let 4x squared minus 9 as our u, derivative of that will be the first power x. So that is what we need here. So let u to be 4x squared minus 9. So du will be 8x dx. We don't need 8, so we just divide both sides by 8. So this will be du over 8 equals to x dx. Rewriting our integral now, we'll have integral of 1 over square root of, well, this one is just u times x dx is actually du over 8. We can move 1/8 outside of the integral, and this will be integral of 1 over u raised to 1/2 du. But we can further simplify this as 1/8 times the integral of u raised to minus half. We can put the variable up but with a negative power du. So finally, we just use the power rule for this integral. So minus 1/2 plus 1, this will be minus 1/2 plus 2 over 2, or this will be 1/2. So this will give us u raised to 1/2 divided by 1/2 plus c. Simplifying this, 2 will go up, so this will be 2 over 8 u raised to 1/2 plus c. Well, 2 over 8 is actually 1/4. Replacing now the u, this will be 4x squared minus 9 raised to 1/2 plus c. For letter b, we have the integral of x multiplied by the square root of 4 minus x. Take note, we can rewrite this as the integral of x times 4 minus x raised to 1/2 dx. Let's try the substitution u equal to 4 minus x. Now, after taking the derivative, we will get du is equal to minus dx. But it seems that nothing happened here because we have x dx. We want x dx here, but in our derivative, we only have minus dx. But we can do something here. We can solve for x. So we have to rewrite x in terms of the variable u. So x here will be actually 4 minus u. This will be negative du equals to dx. So using this information now, we will have integral of our x now is 4 minus u. Well, 4 minus x is actually u. This is u raised to 1/2 times dx is actually minus du. We can actually multiply negative 1 to 4 minus u. This will give us integral of u minus 4 times u raised to 1/2 du. Now note that u times u raised to 1/2, this is just equal to u raised to 1 plus 1/2, which is 3/2. So if we are going to distribute that one, we will multiply u and u raised to 1/2. We will get integral of u raised to 3/2, and then we'll get minus 4 u raised to 1/2 du. Splitting this integral into two integrals, we will get integral of u raised to 3/2 du minus 4 integral of u raised to 1/2 du. Applying now the power rule to the first integral, so we will just add 1 to the power. So 3/2 plus 1, this will be 3/2 plus 2 over 2, or this will be 5/2. So we will get u raised to 5 over 2 divided by 5 over 2, but the 2 will go up, minus 4 times, well, 1/2 plus 1 is actually 3/2, so this will be u raised to 3/2 divided by 3. The 2 will go up, plus a constant c. So rewriting this now, we will get 2 over 5. The u is actually 4 minus x, so replacing that, we will have 4 minus x raised to 5/2 minus 2 times 4 will be 8, and then we have 3 in the denominator. Replacing now the u, this will be 4 minus x raised to 3/2 plus the constant c.